Assalamu alaikum, welcome back. So what I want to do in this session, I want to first review what we have seen last time. So hopefully after the first lab on coroutines, I hope you have a better idea. As I explained last time, you need to practice it, go through these slides and focus with me in this session so you can enhance your understanding of the idea of coroutines. So this will be the foundation for doing web API calls. To access a remote web server, we use coroutines. Also, we will use coroutines when we will do a reading and a writing to a database. So next session, inshallah, I will explain how to read and write from a database using coroutines. But in this session, I want to review what we have seen and address any gaps in the understanding of this very important topic. Okay, so I will introduce the basics and then show you how Coroutines programming model works. And also I will show you some extensions of coroutines called flow. So let's start with the basics. I already explained this where our user interface is running on the main UI. You should do your best not to run anything long running on the main UI, otherwise your UI will block. And this will give a poor user experience and create frustration for your users. And I illustrated this many times, so let me just show it to you one more time. So if I created this small app here, it illustrates these concepts nicely. So in here I have a very simple task where I increment this value. No problem, if there is something very simple like incrementing a value, even if you run it on the main thread, this will not impact anything. The UI is still responsive. But if I have something long running, then if I run it, then my UI now is no longer responsive. So it creates confusion for the user, frustration for the user. And even at certain stage, Android OS will basically recognize this and give this message to the user. They give them the option either to close your app because it's freezing or to wait longer. So you don't want your app to fall into this situation. So what is the solution to this? So one way is to run this long-running task in a background thread, in another thread, where basically your application becomes multi-threading application. You use multiple threads. You run your application, you run this long-running on the background thread. Your UI is still responsive. Can you see here? I can still increment this value. And when the results are ready, they will be displayed. You see here the results are ready and get displayed. No problem. So this long running, the avoiding blocking the UI, blocking the main thread, can be solved by using threads. So as you can see here, what I'm doing here, I have here this long running task in the background. I run it on the background thread. What that means is I call this function thread and I pass to it the long running task. Now when the results are ready, on this new thread, I cannot just go ahead and display the results. So I cannot just go and here the results, I think it's called results, result text view. I cannot just go and set the results in there. So let me show you what happens if I try to access the UI from the background thread, from another thread other than the main thread. So if I run this, and basically I'll go ahead and run this long running thread, no problem, it will run. But when the results are ready, after this long running computation, By the way, this is trying to get a random prime number, and it's long running. It will take some time. So during that time, no problem, the UI will not block because it's running on a separate thread. But unfortunately, I cannot access the UI to update the UI from this background thread. So take a look at this. My UI is responsive, no problem. I call this, no problem. My UI is still responsive, and the job is running on the background. But unfortunately, at certain stage, my app will just crash. Why? Because I'm trying to access the UI from the main thread. You can see here my app crashed. If I go to my log, you can see here only the original thread that created the view hierarchy can touch its views, which means, another way to say it, the background thread, the new thread that I have created to run this long-running task, cannot touch the UI. So how do we solve this problem? Any idea how do we solve this problem? I have the results at my hand, but I'm not able to write it to the UI.
To use to use sync and await.
We come to that. I'm not using coroutines now. I'm just illustrating that I can solve this problem of long running using just threads without using coroutine.
Change the UI from the main thread.
Yes, I need to change the UI from the main thread. That's correct, yes. So how do I do that? So basically, to do that, I need to provide a callback. So when I call this a long-running task that is running on the main thread, I give it a callback. I'll say, when you finish working on this, please call me back. So the analogy of this is, if you have, let's say, if you have somebody has a car problem, a major car problem, so they take it to the mechanic. Now they have two options. You have two options when you take the car to the mechanic. So the mechanic might be busy. Either you will take some karak and sit on some chair and wait there. And you might miss your lecture. You might get some dust and the dirt on your clothes and a lot of issues. Okay, what is a better option instead of waiting? Once you drop your car there, what is a better option?
Tell him when you finish, call me back.
That's it. Thank you very much. You give them your number, and then basically they say you can go and enjoy life, do whatever you need to do. You don't need to block and wait for the car to be ready. Once the car is ready, we will call you back. Give us your number and we'll call you back. Exactly the same is going on here. We are telling this thread, please go ahead, do this long-running task for us. We will not block our UI thread. We will not block it. When you are ready, please call us back. And here, this callback is basically a function that takes a big integer and returns nothing. This is a function. We already familiar with callbacks. You already did this, if you remember, in your view model. Not view model, sorry, your adapter. If you remember your adapter, your recycler view adapter, when the recycler view adapter, some item is clicked, or the delete button is clicked, the fragment or the activity provides a callback. So when the item is clicked on the adapter, when the item is clicked on the UI, the adapter will call the activity to handle the click event. So in this scenario, this is something similar. So take a look at what's going on here. So here I call this function and I pass it another function. So basically I'm passing it another function as a lambda, and this function will receive the results. After this long-running task is finished, the results will be passed to this variable result. And in here, I am able to update the UI, but I must switch to the main thread. So I go here and say require, because I'm in a fragment, I'll go say, please go to the main activity and try to run this in the UI thread. And then I can get the results of the long-running task and display it on the UI, and this will work nicely, no problem. So,
Doctor, we call back the main thread. Why we call back the main thread? Because the another thread, when we call this method, it will consider it as the secondary thread or something like this, or?
Okay, so let me run this one in a small kind of what is it called, in a slow mode, so you will see what's going on. So let me just show you. So what I'll have here, I'll say display results. Okay, sorry, I'll write it here just quickly here. So I create a function called display results. And this function basically takes a string. Here is a result, string. And I put this here. Now, here I just want to ensure, I want to make 100% sure that this code will always run on the main thread. So I'll wrap it inside this require activity that run on UI thread. So here I'm 100% guaranteed this will always run on the main thread. Now, in here, what I have in here, this is a long running task. By the way, this is not, this will be big integer. Okay. So what I will do when I call this long running task, I basically pass to it this function. So what I'm doing, I'm calling this and passing this function as a parameter to this. Why I'm passing this function as parameter to this long-running async? Because this long-running async, this code will run on another thread. When I say here thread, this will create a new thread and run these results. Okay? Now, this thread, as I showed you shortly, cannot access it cannot access the main thread. I was in the main thread here, and when I call this function, I jump to another thread. I'm now in a separate thread. From here, I cannot call the main UI. What should I do? I should call back the caller. So this is similar to your mechanic calling you back. Same thing here. It will call back the caller, and the caller will take the results and display them using the main UI thread. So this is the only way to do it. From a background thread, you cannot touch the UI. So let me just run this, and I will explain it more through this log that you see here. So let me just debug here. Let me just clear it. Here's my okay. So here is my okay. There it is. Okay, here's my long-running task that I will launch on the background thread. Here it is, long background. You can see here, this is now running on thread 2. It's no longer on the main thread. By the way, sorry, just a second. Let me just put this here as well, just to show you that these two are running on two separate threads. Running on thread, okay? Let me put here .name. Let me put also here .name. And let me rerun this. So this will be very clear to you. that the fact that I am running this inside this thread, so this will run on a separate thread, and because it is a background thread, it cannot access the UI. Okay, so okay. All right, so here is my main UI. There's no problem in here. This is small, not long running. My UI is still responsive. Here is a long running one. I run it. You see here I switch to thread 2, and it's doing the long running task, that long computation. But my UI is still responsive. You see here it came back. When it came back, it switched to the main thread to display the results. Okay? So this problem of long-running task, avoiding a long-running task, and not blocking the UI can be solved by using multi-threading. And we can create multiple threads to run our results. Allahu Akbar. But we encounter immediately a big problem, which is how do we communicate the results back to the main thread? Knowing that the UI can only be touched from the main thread, as I illustrated to you. So to solve this problem, you need to use callbacks. So when you call the network, when you call which I illustrated here nicely, when you call the long-running task, you pass to it a function. And this is a callback. So when this long-running task finish, it will call your callback and give you the results. Now, this is a kind of babyish way of doing it. Professional developers, they just take this function here and just pass it in here as an anonymous function. That's it. This is exactly the same. And here it's a result. So here I'm creating an anonymous function. Here I'm creating an anonymous function that takes, here I'm calling this function and passing it this extra function, this callback function, okay? So let me see what's going on here. Why is it complaining? And resolve long running. Okay. Okay, so hopefully, yep. Okay, so that's it. Now this is one way of solving the problem, but this way has two limitations. First of all, threads are costly. Every time you run a new thread, it will occupy from 1 to 2 megabytes. Plus, you should take care of some special threads, such as the main UI thread. For example, you cannot update the UI except from the main thread. So you need to be aware of these limitations and not violate this rule. Plus, to communicate between the background thread and the main thread, you need to use callbacks. Callbacks are fine for simple scenario, but for complex scenario, callbacks can become complicated, and this is known as a callback hell, particularly when you have nested callbacks, a callback within a callback within a callback. So luckily, recently, I think this is introduced in 2017, 2018. In Android, you no longer need to use callbacks. You no longer need to use threads to achieve this ability of running long-running task on the background thread. You don't need to use threads. You use something called coroutines. So coroutines are lightweight threads. Plus, coroutines allow us to run computations that can be suspended and resumed. And I will explain this shortly. And coroutines are really needed, and they are typically needed and used whenever we want to make a call to web API, some network remote call via the network, or if you want to do database operations like read and write to a database, or if you want to do some complex computations, you better do them on the background thread and then report the results back to the main thread. And coroutines allow you to do this in much simpler way. So what we have here, let me show you. First of all, you can think of the difference between threads and coroutines. As I explained last time, you can think of threads as construction sites, and coroutines are workers in those construction sites. So in a thread, we can have multiple coroutines. So the coroutines are much more efficient than threads. In terms of resource usage, they are much more efficient. And with threads, with coroutines, we don't need to use callbacks. For example, in here, I have this get news, which is long running. All I do, if I want to switch to the background thread, I use this function called with context. And then I choose which background thread I'll be using. For example, this one will be making a call through the network. So I will switch to the IO thread to run this. And the function will suspend. Will basically suspend, stop running without blocking the UI thread. And when the results come back, we switch to the main thread very easily with this function called with context. And I say go back to the main thread and display the results. So you can see my code is much easier to understand. It looks more sequential and compared to the callbacks. Except these are just like context switching. You switching from IO thread for long running network call. And when the results come back, you switch to the main thread and display the results. And this ensures that your program, your UI stays responsive, your main thread is never blocked. And also the long running tasks, your program will always run them on the background thread and then come back and display them on the main thread, display the results on the main thread. So compare these are two solutions to the same problem. In here I'm getting the user object from a remote web API using the username and password. This will return a user. And then I take the user and store it in the local database. So using callbacks, it's not that easy, as you can see here. It's a bit confusing and much harder to understand. But with the coroutines, it's much easier. You can see here, this looks like sequential code. I first go to the remote web API and get the user. Then the returned user, I take it and store it in my database and then return the user back to the caller. So this looks very similar to sequential synchronous code. And the compiler will generate the scary code, the callbacks to do all of this. So to summarize, coroutines, you can think of them as lightweight threads. They are much easier to use. And the other thing, they make it easy for us to do exception handling and cancellation. I will show you shortly that when I run a coroutine, I can cancel it if I no longer need the results, or if the user navigates away from the activity in which they requested some long-running task, I can cancel that task whenever I wish. I can also switch context very easily. I can go to the UI thread, do something. Sorry, I can go to the IO thread, do some work, go back to the main thread, and access the UI very easily with one simple function called with context. And asynchronous programming becomes much simpler, and it looks similar to sequential code. Your code will become similar to sequential code without any callbacks. Those are basically the advantages of using coroutines compared to using threads. Now, for coroutines programming models, to use these coroutines, you need to create suspend functions. Instead of creating normal functions, our functions that have long-running tasks that basically suspend and resume must be flagged as suspend. So suspend functions are normal functions that we are used to, except we come in front of them and put the keyword suspend. Now, once we put that keyword suspend in front of them, what happens is when the runtime reach that a suspend function, basically the program will suspend execution until the results are ready, and then when the results are ready, that function will resume execution. And all this is happening without blocking the UI thread. So you can think of them this way. So the normal functions that we are used to, for example, these functions that I showed you last time, let me show you. In here, let's say this function, let's say add. We are familiar with this. This is non-suspending function. This function simply, you call it, the caller needs to block and wait for the result to come back. This is no issue because this is not long running. It will be super fast. No problem. We can afford to do this. But if we are, for example, going to the network, going through a network call to a remote web API and asking for stock symbol for a particular company. For example, for Amazon, the stock symbol is, let's say, EAMZN. For Salesforce, the symbol is CRM. We want to ask, give me the symbol for this particular company, the stock symbol for this particular company. So this could be long running. Because this is a long running, I come and flag it as suspend. So I put suspend in here. So what happens is, when I start running this function, I basically here I print this text here, and then here I'm simulating that the function is suspending. Basically, it's going to suspend and wait for 15 seconds. Sorry, for 1.5 seconds in this scenario, and then it will give me the results by looking up this map. So if I give it Facebook, it will give me the symbol as FB. If I give it IBM, the symbol will be IBM. Okay, so suspend function is a normal function that is flagged with suspend. And because it is suspendable function, what happens is it doesn't block. You call it, it will do a bit of work. If it encounters a long-running task such as reading from a network, it will suspend. And as the caller, you don't need to block. You can keep doing whatever you need to do. And when the results come back, the results will be communicated back to you, and the function will resume. The suspend function can suspend and resume multiple times. So this is what's special about these suspend functions. Now, once I have a suspend function, here is my suspend function. Once I have suspend function, there is a limitation here. I cannot call it. I cannot just come to another function and call this. You see here, the compiler will tell me suspend function should be called only from coroutine or from another suspend function. So suspend function, I cannot call it in another normal function. It must be suspend function or a coroutine. So let me show you what I mean by this. So in here I have a suspend function called get stock symbol, and in here I have another suspend function called get price. As I illustrated last time, if I want to get the price of a particular, the share price of a particular company, it is a two-step process. I need to get the symbol of the company, then I'll go and ask for the price. So if I say here Facebook stock price, so it will tell me here the Facebook stock price is $256. So first, this lookup, if I want to do it programmatically, I need to look up what is the symbol of Facebook, which is FB, and then I do a lookup of the price. So this is exactly what's going on here. I do a lookup of the symbol, which is a suspendable function, and then I do a lookup of the price. So in here, if somebody wants to know the price of Microsoft, they will call this function stock quote, and they will give here Microsoft. And then what I do here, I switch to the IO thread, and I run these functions here. I run the symbol, I run get symbol to get the symbol of the company, and then I go ahead and get the price, and then I return the name of the company, the symbol, and the price. So because this is a suspend function, no problem, I can run it this way. If it's not a suspend function, I cannot call this directly. Okay, so let me illustrate this quickly. So let me go back to my, if you remember, we had this example here. And here is my long running task. So let me just comment this. So what I will do here, in fact, let us do this quickly together. So without using callbacks. I think let us convert this so you get, hopefully you get the idea clearly. So here is an async, and here I create another version. Here I create another version, and I will call it a long running. Okay, and I will mark it as suspend. Okay, and basically in here what I will do here, I will say here with context and dispatcher dispatchers. I choose here which thread I want to run this, because basically we have three main thread pools or three main thread groups that I can use. Default is recommended if you have a long running computation. IO, you use this if you want to do a read and write from a network or from a database. And main, this is if you want to access the main thread. So because this is a long running computation, let's run it on the default thread. So this will go ahead and do the work. Okay. Okay, and then what I will do here, once it's all ready, let me just return, okay? Return results. Return. Yep, return with context results. Okay, so it's a normal function. The only difference is that I switched to the IO the default thread to run this long-running function, and I marked it as suspend function. Okay, now for the main thread, from the main thread, what I will do is, because this is now a suspend function, I cannot just call it long. Did we call it a long running? I cannot just call this. Can you see here what it's saying? Suspend cannot be called from, can only be called from coroutine or suspend, another suspend function. So I need to run this in a coroutine. So how do I create a coroutine? So to create a coroutine is basically coroutine. You can think of it as a container where I can run a long-running task, or I can run suspend function. So because here I am in a fragment, there are some built-in scopes that I can use to create a coroutine. So I can go here and say lifecycle scope dot launch, lifecycle scope dot launch, and I can basically launch this task here. Now in here I don't need to have this callback. There's no need for any callback. We don't need callbacks with suspend functions. Basically, in here I will say val result equal long running. So this is suspend function. I am able to call it from a coroutine. So the compiler is happy now. So if I uncomment this, the compiler will say no, you can only call this from coroutine. How do I create coroutine? I'll go to scope and then I call this. Then once I get the results, what I do, I'll switch the main thread with context dispatchers.main, and in here I can now, yes, in here I can basically, yes, inside here I can access the main thread. So I'm able to switch to the main thread. I hope it's clear here. Now, why do we need this lifecycle scope? The main reason, one of the main reasons, is that what I can do here, I can store this in a job. This is a long-running task. And if need be, I can provide the ability to the user to basically cancel this if they want to. So the reason why, if the compiler allowed me to run this outside the coroutine, I will not be able to cancel it. So because I'm running it inside the coroutine, I can, if there is a need, I can cancel this job. Or in our case, if I close this activity or this fragment is destroyed, this job is automatically cancelled. That's another very important aspect. So when I'm doing something long running, if the user navigates away from the activity that launched that long running task, this lifecycle scope will automatically cancel this long running task automatically. And this is very important because you don't want your mobile app to be doing things that are no longer needed. It will waste memory, it will waste battery. If it is doing it over the network, it will waste network bandwidth. So you don't want that to take place. So, and this will be automatically cancelled if the activity or the fragment in this scenario is destroyed. Okay. All right, that's it. This is basically what is going on. Unresolved. Yep, I need one more here. What is the next probable number? Cannot find declaration. Yeah, yes, here is a long one. Yes, that's it. Here it is. Yeah. Okay, that's it. This will work, and you can see here it's much easier. I can try it. You will see it will work, inshallah. So basically, I converted from using threads to coroutines. So instead of using threads, I'm using coroutine. And with coroutine, all I do, I made this function suspend function. And when I run it, I choose which dispatcher to use.
Doctor, I have a question.
Yes, please.
Will the coroutines, they will do the same performance as the threads?
A much better performance. Let me illustrate this while this one is trying to reboot. Let me illustrate this. You see here, I provided an example here to really illustrate the difference. Much, much better performance. Take a look at this. What I'm doing here, I'm running I'm starting 10,000 threads concurrently and waiting for them to finish the work. Just displaying one dot. 10,000 threads. And I'm computing how long it takes to run these 10,000 threads and do this simple work. So let me start this work here. Here it is, run. Not sure what's going on.
Actually, I got the new update. It is very, very slow.
Yeah. Okay, so let me just run it. Let me stop this guy. Okay, so let me run this. So I'm running this one using threads, and I'm running exactly the same 10,000 coroutines. I launched 10,000 coroutines. So this is running the threads, and this is running the coroutines. Here it is. Exactly the same functionality, and we will see the difference in terms of performance. So these are coroutines running, and this is threads running. Threads are still going. Coroutines. And this one, the threads, you will see it will take much longer. Yeah, so this one took 34 seconds. Yes, 34 seconds. Look at this. Coroutines, it took 7 seconds. Exactly the same work. So definitely coroutines are much lighter weight, much faster than threads. And that's the advantage of them. So let me go back to the slides and just illustrate. So I hope the idea of suspend functions is clear. So suspend function, it is able to suspend and resume and never blocks the caller. Now for the suspend function, you can only call it from a coroutine or from another suspend function. Now, what do we mean by calling it in a coroutine? You need to start a coroutine for you to be able to run suspend function. How do we start a coroutine? So to start a coroutine, you need a coroutine scope. It's a new concept that Android have introduced. In fact, Kotlin, the Kotlin language. By the way, these innovations of coroutines and this concept that we are covering, it's not specific to Android. This is coming from Kotlin language. Android is just making use of it. And of course extends it. So Android gives us this two special scopes that we can use to launch coroutines. There's a view model scope. It's already there and available. If you are inside the view model, you can just do view model scope.launch. And inside that view model scope.launch, you can run your suspend function. If you are in an activity or a fragment, you can use lifecycle scope.launch. And in there, you can launch your suspend functions. And there is global scope. This comes from Kotlin. But this is rarely used. You should not use it. Because this one is the long-running task. If it is a long-running, it might not be suspended until the application stops. Then the long-running task will be suspended. But if you do this way, for example, inside the view model, you go and say view model scope.launch. When your view model is destroyed, anything you launch inside this view model scope will be automatically cancelled when this view model is destroyed. Same thing with the lifecycle scope. If you are inside a fragment and you say lifecycle scope.launch, anything you launch in here will be auto-cancelled when the user closes this particular fragment. So please make sure you use this view model scope or lifecycle scope to launch your view, to launch your coroutines. The other advantage that this gives you is that you will be able to cancel if you wish. So let me show you here. In here, what I have this fragment, this cancel coroutine. Here I started this coroutine here and assigned this to a job. So when the user clicks start, I launch this coroutine. It will keep running forever until the user decides to cancel or until this view model is destroyed. So if the user asks for canceling, all I do, I go to the job, check if it's still running, and I go and say, please go ahead and cancel it. So that's another advantage of coroutines. Coroutines, I must run it within a scope, and that will return me a job, and I can cancel that job if I wish to. With a normal function, I can never be able to do this. I cannot cancel a running function. But with coroutines, I can cancel a running function, which is another major advantage. Especially in the context of mobile application, we don't want to, the battery is limited, the bandwidth is limited. If we are running a long-running task and the user switch to another activity or closes that particular window or that particular activity, we don't want that task to keep running. It's a waste. We want to cancel it. And coroutines and coroutine scopes allows us to do this. The other thing coroutines allow us to do is the ability to run things in parallel. So let me show you, and this is the last thing I want to show you here. In here, this is an example of running this in sequential order. So I'll go and get the code for Apple. So this function will suspend. Once the code is back, I can display the results. Then I call another function, another call to get the code, the price, the stock price for Tesla, and I'll do the same for Google. And then this will be running, and then once the job is completed, I will compute the total time it took and display the result. So let us run this. As you can see here, let me run it. I think it will take around 10 seconds because it will do sequentially, one after the other. So it gets the stock for Apple. This is the Apple stock, 460. This is the Tesla stock, 384, and it is the stock for Google, 380, and it took 10 seconds. Now, look at the same code, exactly the same, not the same code, I mean exactly the same goal, but in here I'm running it in parallel. It will take third of that time, almost 3 seconds. So here is the parallel version. So it's running. So I get the symbol of Google and Apple and Tesla at the same time. I run these in parallel, and you can see the execution time is 3 seconds, less than third of the sequential version. So how do I run things in parallel? So inside the coroutine, I can start another job. In here, because I am expecting a result to come back, I can call async. Instead of just calling the suspend function, I call it within an async function. And this will give me a future value. In the future, I can wait and get the value. So these 3 lines are executing these 3 functions in parallel, concurrently. Once I launch them in parallel, I'll wait for the results for each one to come back. So this will give me the results for the Apple stock. This will give me the results of the Tesla stock, and this will give me the results of Google stock, and I display them. And this will take basically, it will take the time of the longest one. Because each of them take 3 seconds, I'll get the results in 3 seconds. So that is how I run in parallel. And by the way, when I launch this task in asynchronously, I can cancel it if I wish. If I don't need this result anymore, I can say here, go ahead and cancel. Of course, if I go ahead and cancel, don't expect there is any results. I cannot get this result. So either once I launch the task, it's now running, I can either wait for it to collect the results, which means this function will suspend until the results are back. When the results are back, this will be awaked and resume and display the results. Then when the result of the second call is back, we resume and display the results. When the third function result is back, we resume and display the results. And when the whole job, which is this global scope launch job, this is a job. In here, I didn't use a main, let's say, view model or activity scope because I don't have them. This is a standalone program. So I'm using this global scope. And basically, I wait until it is done. When it's completed, I display how long it took. So this is the parallel version versus the sequential version. So this sequential version. And by the way, if I have some parallel, but I don't care about the results, I just want to run them in parallel, I don't care about the results, then I can just use launch. So the difference between launch and async is with async. Sorry, here it is. With async, I can wait for the result. With launch, we usually use it in the scenario of fire and forget. We call, but we don't care about the return value. So we can use launch. That's the difference between the two. So here, this is parallel launch. Let me run this one. So these will be run in parallel. And you can see here, although this one I started early, but the results came last because this slept or suspended for 1.2 seconds. This one suspended for a little bit more, 600 milliseconds, and this one suspended for 300 seconds. Because these are launched in parallel, of course this one will finish first, then followed by this, then followed by this. So these tasks run in parallel. That's another power of coroutines. You can run things in parallel. So to summarize very quickly, coroutines very powerful alternative to threads and callbacks. We don't need to use callbacks. They are much lighter weight and much faster than threads. They allow us to launch jobs and cancel if we want to. If we launch a job using a view model scope or activity or lifecycle scope, those jobs will be automatically canceled when the view model is destroyed or when the activity is destroyed. The other things is we can run things in parallel. So these are the advantages of using coroutines. And the code much simpler, and it looks like sequential, although this code is not sequential. This code is basically asynchronous. In fact, this is running in parallel, and when they are running in parallel, the program will suspend. This program here will suspend, or this function here will suspend. When the results are back, we resume execution. This function will resume execution and display the results, and do the same for the other 3 calls. But it's much easier to reason about compared with callbacks. So that is the idea. So inshallah, next time I will show you applying coroutines to fetch data from a remote web API, and also we will apply coroutines to read and write data from a database. So coroutines now are an essential skill that you really need to master, because it is heavily used instead of threads because of the advantages I have illustrated. And whenever, basically this is the summary, whenever you want to do any of these things, do a network call, so web API, do a database operation, or do a complex computation, you must use coroutines instead of threads, and in much simpler programming model. Okay, that's it for this session. Inshallah, if you have any question, please let me know. Otherwise, inshallah, I will see you on Tuesday. Okay, I'm still around for a few minutes. If you have any quick question, I can